Gas metal arc welding is often referred to as MIG welding, which stands for metal inert gas. The main variables that affect the type of metal transfer include shielding gas, wire type and diameter, wire feed speed, electrode extension, and voltage. We'll discuss these variables as they apply to the various metal transfers. The characteristics of GMAW are best described by the four basic modes of metal transfer which occur with the process. These are short-circuiting metal transfer, globular transfer, spray transfer, and pulsed spray transfer. The type of welding to be done determines which of the transfer methods to utilize. Short-circuiting is a common type of metal transfer used in the continuous wire process. In the short-circuiting mode, all metal transfer occurs when the electrode is in contact with the molten puddle on the workpiece. Because the arc is not continuously on during the short-circuit transfer, the heat input is lower than other modes. This fact limits its use for heavier sections but makes the process ideal for joining thinner metals. Also, the intermittent cooling of the puddle provides for good control in out-of-position joints. When short-circuiting parameters are set correctly, the arc has a characteristic bacon frying sound. This transfer adapts well for a thin-gauge body shop type application. 023 wire diameters are often selected with either a mixture of argon and CO2 gas or 100% CO2. Short-circuiting also adapts to out-of-position welding on a variety of metal thicknesses. On metal thicknesses greater than 3/16 of an inch, a more efficient welding process is through the use of a tubular wire called flex cord arc welding. However, on properly prepared plate and pipe, metal thicknesses of a ½ inch and thicker can be successfully welded with short-circuit transfer. This transfer is especially useful on open root joints where a fast-freezing puddle is required for puddle control and good penetration. Parameters will vary with wire type and diameter, as well as shielding gas, metal thickness, joint design, and position of welding. A common wire diameter of 035 steel will operate best in the range of 50 to 180 amperes, 80 to 380 inches per minute of wire feed speed, and 15 to 22 load volts. Globular transfer takes place when parameters are between short circuit and spray transfer. Due to large globular droplets, the transfer is erratic. This results in spatter and poor weld quality. Production welding applications can successfully apply a high amperage and voltage parameter with argon and CO2 gas mixtures. This globular to modified spray transfer produces fast, yet quality weld results. Spray transfer is used for metals about an 1/8 inch and thicker in the flat position. The characteristic humming sound is a result of adequate voltage and amperage to pinch the wire off in small droplets. Spray transfer also requires an argon-rich shielding gas. On carbon steel material, up to 5% oxygen or 10% CO2 can be mixed with argon to provide proper puddle wetting action and prevent undercut. A common wire diameter of 035 steel will operate best in the range of 165 to 300 amperes, 340 to 625 inches per minute of wire feed speed, and 24 to 30 load volts. Welding stainless steel with spray transfer, the argon gas is generally limited to a mixture of 2% oxygen. Aluminum material, an 1/8 inch and thicker, is generally welded with gas metal arc welding, spray transfer. This material requires 100% argon shielding gas. Pulsed spray is a unique type of transfer that uses lower than true spray heat input parameters, yet pinches small droplets off in a spray type transfer. Here, the pulsed spray transfer arc has been slowed 200 times. What we're seeing actually took place in about 1/15 of a second. The power sources or pulsing accessories used for pulse spray are especially designed for the process. Either 60 or 120 pulses per second can be selected at the front panel. When in the standard position, the output is not pulsed. With inverter-type machines, the frequency is often variable, not fixed at the specific pulse frequency. The wire feeder and gun are the same as used in other gas metal arc applications. Some of the pulsed spray advantages are all-position welding with spray-like transfer, using large diameter wires such as 1/16 ER4043 aluminum, no problems with spatter, good mechanical properties for various metals, good fusion avoids cold lap problems, varied material thickness from 20 gauge up to 1.5 inches and thicker, minimum distortion on various metal thicknesses. Some of the pulsed spray limitations are lower deposition than spray transfer due to lower wire feed speeds, limited use of open root or poor fit-up. Low heat input results in limited yet adequate penetration. Cost of machines increase as sophisticated controls are developed. Ease of setting parameters has been improved with developments of synergic type controls. Pulsed spray has many advantages for certain applications. As technology advances, new applications will no doubt be uncovered. In review then, the gas metal arc transfers can be separated into 4 basic modes. The short circuit is characterized by the bacon frying sound for a fast freezing puddle. The globular transfer is generally an erratic arc to be avoided. The spray transfer is a steady humming sound for high deposition, deep penetrating production type welding. The pulsed spray transfer is unique and has specialized applications. Gas metal arc welding will indeed continue to expand in various applications throughout the welding industry.